All right, so here's what we got. Okay, this is just like a similar triangle question, okay, in case you missed yesterday, okay, which will help you. If you didn't get it yesterday, we'll just do another question, see if it resonates today, and then you guys can try that formative, okay, that I put up, formative 7. It's all about similar triangles and then Pythagorean theorem. Okay, so here's what we got. We've got a 2-meter tall shadow, and I don't know what's supposed to be here. There's words missing, but anyway, we got a similar and a person. Yeah, it's jumping around. Okay, so it looks like we're supposed to read from here, and then over here, and then I think it somehow comes find the height of the tree. This is a funny. I don't know what happened here. Okay. Oh, true. Okay, thank you. You guys can't see the screen anyway. All right, so here's what we got. Okay, I hit record anyway, so it's all there. But something happened with this question. It's all over the place. So I think it's when a oh, I see. The picture's right slammed in the middle. So I think you go when a person who is 2 meters tall casts a 3-meter shadow. A tree is 30 meters shadow, something like that. Okay. Anyway, it's in the picture. We're basically just solving the two triangles that are in the picture. Okay. So here's what we got. We're just going to draw 2 triangles. Okay. One is going to look like this. I'll draw the little one first. Okay. We've got the little one in blue. I'll try highlighting it. Okay. Got a little triangle in blue there. Okay, so then we're just going to draw it. Okay. 3 meters by 2 meters. Okay. So we got 3 meters and 2 meters. Okay, and then we also have another triangle there, a big one, that's created by the tree. Okay. And it's colored in green. So if I were to draw that one, it'd be a little bit bigger. Okay. On it, it's going to be 30 meters long. And we want to figure out, well, how tall is the tree? X. Okay. So this method, okay, I showed you 2 different ways yesterday, but I suppose you could look at these 2 triangles side by side once they're drawn like this, and this is why I was trying to push you towards drawing 2 separate triangles yesterday when we did all this work. If you look at how do I get from the small triangle, or this particular side, because they're side by side here, you can see the similar side lengths, right? One's 3 meters and 30 meters. So your question is, okay, well, how do I get from this side length to this one? How do I go from 3 to 30? Well, you multiply by 10. Right? So if you were to multiply by 10 there, we're going to consider this as like what we call our scale factor. Okay? So if I multiply by 10 there, I have to multiply by 10 here to find x. So x is going to equal 2 times 10. I'll put those in brackets just so. Okay? That's if I just drew the picture side by side. You could, if you had a more complicated question for whatever reason, right? The numbers weren't so nice, or you weren't able to just extract the 2 triangles perfectly, you could just write, okay, you could say, okay, 3 meters over 2 meters has to equal, where's the 3? The 3's on the bottom, so you're going to take, okay, the bottom over x. Right? And you could use any of the 2 methods that I showed you yesterday as well, right? Where we said, okay, well, you could multiply by 10 here. This is just kind of the same thing as the picture, but it's just a little more organized, I suppose. Or it looks a little bit more like math. You could also find the number, what this number is, right? Be 1.5. And then you could solve, right? You could say, okay, well, 1.5 equals 30 over x, and you could solve it, right? So you'd go multiply both sides by x, you'd get 1.5x equals 30, right? Then you can say x is equal to 30 divided by 1.5, which equals 20. Okay? Any of these ways work, okay? You could also, if you like the solving method of cross multiplication, you could do that as well. Okay, if you wanted to cross multiply. Oh boy. Right? So that would be, how would you do this? So it would be 30 times 2 would be 60, right? Is equal to 3x. Solve for x. Well, x would equal 60 divided by 3. Okay, any of these will work. The blue, the black, or the picture above, okay? With similar triangles. They're kind of nice questions. Okay. Does anybody have any questions about that? Okay, that's like, there's one of those questions, just a similar triangle question on the formative, okay? Just so you guys can give it a go and see how it turns out for you. Okay. That's just an introduction. Between yesterday was kind of an introduction into trig, right? Where we'd kind of seen, you guys have seen scale factors before, proportions, right? That should be all grade 9. I did a lot of that in grade 9. Pythagorean theorem, it sounds like a few of you have seen that as well. Okay. So that forms the basis of your trig knowledge up to this point. Okay, where we're headed now is maybe something you haven't seen before. Okay. This is what we really kind of define as being trig. Okay, so we're going to have this thing called the tangent ratio. Okay. And it's used to determine like the steepness of a slope. Okay. Now, I guess we could kind of relate this back to our slope dude, which is kind of cool, right? Because your question here is like, you want to push this box up the hypotenuse, right, of one of these two triangles, or both, I suppose. And your question is, which one's going to be harder to do, right? So would you rather push the box up, we'll call it ramp A, or would you rather push it up ramp B is your question, right? Okay. Does anybody have any insight as to which one they might choose? Like, for instance, you're just looking at the numbers that are present here, right? So for instance, would I prefer to push 11 meters, even though it's not as steep? Would I prefer to push 11 meters, right? Or would you prefer to push 5 meters at a slightly steeper angle is your question. Okay. What do you guys think? Okay. Well, we could figure out if we use our like something that we're more familiar with, right? From the standpoint of we know like slope, we define slope as being right. Ethan, you can't hear me? Why can't you hear me? Everybody else hear me okay? Okay.
I can hear you fine.
Okay. I wasn't talking there for a sec, buddy. I don't know if I was just waiting for you guys to do something. Okay. It's like, it's hard talking just to a screen because I don't really expect you to respond, but I do expect you to respond, but it's tough. Okay. So here's what we got. We got slope equals rise over run. Okay. So I guess our question is, like, if we're standing in our box, the rise is going to be over here, right? That's how far we're going up. And the run is going to be here. Okay, same thing over here. Standing at the box, we're going to try and push it up. Rise, we're going to have to go up 3 meters. But we're going to have to go along 5. Okay, so let's just figure out slope of both of these. So slope of A, rise over run, which is equal to 3 over 11, which should give us a decimal value of 0.27. Okay. Now if I go over and do the slope of B, you're going to say, okay, the same thing as rise over run. And you're going to say, okay, well, it's 3. You're going up 3 over 5, which should be 0.6. Okay, does anybody have any questions with that? Good. Okay, buddy. Good. Okay, so remember what this is a measure of. This is like how steep is, like how puff positive is this? Right? This doesn't seem as steep. And we can see that in the number that we found too, right? So this looks like it's the better option at the moment, right? But over here you've got, this looks very puff positive-y, if that makes sense. Okay, it looks very steep. Okay, but there's two parts to this, right? You've got how steep is the incline. Okay, it looks like right now this one's winning, right? Because it's not as steep. But your next question should be, okay, well, how far do I actually have to push this box, right? Because that's also going to play a role as well. So you're like, okay, well, how far do I have to push each box to get it up to the top? Well, we can figure that out now, right? Let's say, okay, well, if I want to end up here on both of these, we could figure out how long I have to push it. You know? So you're saying, okay, that looks like a right angle triangle to me. Right? So okay, we can use something. This is C. This is also C. Let's use the Pythagorean theorem and figure these out. Well, we can go a squared plus b squared equals c squared, right? On both of them. And because it's c that we're looking for, we're not too worried about where to put what, right? So we can just go 11 squared plus 3 squared is equal to c squared. And we're going to get 121 plus 9 is equal to c squared, which is the square root of, or sorry, c squared is going to equal 130. So c is going to equal the square root of 130, which should equal 14.4. Oh, sorry, not 14.4, 11.4. Okay, that means you're going to have to push the box 11.4 meters. Get rid of some writing here. Not useful writing. Okay, we're going to have to push it 11.4 meters up this incline. Okay, so you have to take into consideration both of these two things, right? Well, what about over here? How far are we going to have to push this one? Well, we could go 3 squared plus 5 squared has to equal c squared. 9 plus 25. So we get 34. Okay? This is what we're trying to figure out. It's not just about triangles are not just about side lengths, right? They contribute to something else that we're ultimately interested in. And I kind of alluded to this morning too, about if we're designing a road or a construction site that needs to be perfectly flat, we need the angle, right? We're interested in, with triangles, there's always side lengths and angles. Okay, so this morning, or even yesterday with the Pythagorean theorem, we only really concentrated on being able to work with the side lengths.